Hello, everyone. My name is Yves Pagal-Vinet. I'm a senior product advisor for Bell Canada. I'm working specifically on network slicing, orchestration, and service assurance strategy. What we're going to talk about today is how network slicing is another step towards full network disaggregation. So what I will be presenting today is to reiterate what is network slicing, what are the components of a slice today and tomorrow, what will be changing over time, and how further, disaggregation could benefit network slicing. Then finally, at the end, we'll try to address the question why telcos and CSPs are betting massively on disaggregation cloud native capabilities. So what is network slicing? Slicing is about allocating and stitching together a set of network resources. These network resources belong to different service domains. We have the RAN domain, the transport network domain, the core network domain. Then these resources can be allocated to any enterprise verticals and application that need to meet specific performance requirements. Typically speed, latency, coverage, capacity, reliability, and power savings. So if you look at each domain, they are supported by domain orchestration capabilities. For slice automation, we call that, the NSSMF. So network slice subnet management function. So each domain will have its own NSSMF, RNSSMF for the RAN, TNSSMF for transport, and for the 5G core, CNSSMF. Each orchestration function will be then supported by a data analytics function, which will be slightly different on the 5G core domain because this is supporting a different kind of approach that is called network data analytics functions, also called NWDAF, which is extremely famous on the market nowadays. Also, what is interesting is that all service domain are supported by an end-to-end slice management and orchestration service layer. This orchestration service layer provide a network slice management function that is the NSMF, that is instantiating and managing the end-to-end slice. And on top of which you will find the service assurance and analytics framework that is supported by AI ML algorithm. And on top of the OSL, you will find the OSS BSS layer that will provide then the CSMF, the communication service management function. And if we look at the components of a slice today, what are they? If you look at the top left corner, you can see the OSL orchestration service layer that provides the customer portal that will provide as well an API towards the BSS layer and the CSMF. But not only that, it will support an end-to-end inventory, a state DB, in order to understand what's happening on the near real-time, what is the state of the component and of the inventory and the NSMF. As I said, NSMF is the end-to-end slice management function. And then below you will find on a per domain perspective, some the NSSMF with their own inventory. So the RNSSMF, what it does, it will instantiate a RAN slice subnet. The RAN slice subnet will be a partial set of resources coming from the GNODBs, which is a hardware, affiliated function. Then the TNSSMF on the other side will instantiate the slice VPN that will be, once again, a set of resources coming from the CSR, cell site router, top of the rack switch, provider edge router, and the EVPN capability for data center. Then finally, we'll have the core slice subnet that will be the set of network functions that is coming from the 5G core. All you see is just a subset of the network functions. I needed more space to have more, but this is a good description. And obviously, all slice subnets represent the end-to-end network slice, which is uniquely identified with the S and SSAI. Each service domain will be then, each slice subnet will be then supported by data collectors. The data collectors will be basically collecting data that will be important for fault management, performance management, but also alarms and this kind of event and anomalies that could be detected. And obviously, NWDAF will provide some QoE data, quality of experience. Then everything will converge towards the Kafka event bus that will be feeding the service assurance architecture. So what you see is, as a result, you have an implementation of the 5G network slice that is based on hybrid composition, mainly PNF on the RAN and the network side, and what you see, and CNF on the core domain. Now, what is important to see as well is network slice observability and monitoring is very important. That level of complexity can't be sustained if you don't have observability and monitoring. And of course, what you need is you need to ensure an open loop communication path from the service assurance architecture and the orchestration service layer for defined event anomaly patterns and root cause analysis. And finally, the main use cases supported will be EMBB and FWA, fixed wireless access. Then at the end, what we can see is today's network will have a strong hardware dependence, specifically at RAN and network domain. If we look further, down the road, what we'll see is that there will be some changes. What are they? So if you look at the OSL itself, there will be some change. Terraform will be part of that. That will be a tool that will be helping to instantiate, workloads on hyperscaler environment. And at the same time, the near real-time RIC is coming from, the ORAN Alliance that is pushing for Open RAN. And the non-real-time RIC will be accompanied by the near real-time RIC at the bottom of the slide. That will be providing the capacity of instantiating the OCU and ODU, but also managing these functions. So once again, what you can see at the RAN slice subnet is the change. Well, there's no GNODBs anymore. The GNODBs have been disaggregated to leave space for ODU and OCU. So the ODU will be residing on the MAC closer to the radio unit, and will be communicating with the radio unit using a frontal interface and EC3. And then the ODU will be then communicating with the OCU leveraging middle interface. But once again, the T and SSMF will still be used in order to instantiate the slice VPN. But obviously what is important to notice is that now the functions that were essentially hardware attached in the past are now fully disaggregated. The CSR, will be basically a CNF that will be running on top of any equipment, any compute. And the top of the rack switch will be the same. We'll have a NOS, a disaggregated NOS, network operating software. And the provider edge routers and the EVPN will be based on the same principle. And then once again, the TNSSMF will obviously instantiate the VPN ID. Then Terraform will be used in order to instantiate the workloads for the hyperscaler edge slice subnet, and will be attached to the VPN of this slice. And the main difference that you could be noticing there, it's actually three elements. First of all, the OCU. As I said, the GNODBs have been splitted into two functions, ODU and OCU, and the OCU will be residing at the edge, and the UPF itself will no longer reside at the core network environment, but will be moved closer to the end user in order to meet latency and throughput requirements, and the near real-time rig that will be managing the ODU and OCU will be located at the edge as well in order to manage OCU and ODU. And obviously, everything will be now once again supported by data collectors. And obviously, NWDAF will do its role to collect QoE data. What you see now as a result, the OSL introducing additional tools and capabilities towards cloud native functions, and further disaggregation of with Open RAN and network domain will accelerate the cloud native transformation. More advanced and granular monitoring will help naturally to evolve towards closed loop capabilities and automation, which will help in order to reconfigure a slice on the fly. And obviously this transformation towards cloud native will simplify and ease the pain of the introduction of new use cases, typically URLLC and MMTC, due to near real-time capabilities and also the support of middle and frontal interfaces in order to meet extreme level of latency and throughput requirements. What you see now is obviously the change is obviously to introduce more cloud native capabilities and more agile orchestration options. So why is it so important to evolve towards a disaggregated and cloud native tools? Well, the goal is to ensure market differentiation, the ease in introducing new level of services that will be that will be massive and extremely important for each telcos, MNOs, and CSPs to differentiate on the market, but also to have more agility in services definition and control. It means that we could anticipate the need to scale at will services horizontally, but as well vertically, which will mean that we'll have more flexibility in addressing moving requirements. Better flexibility in introducing as well new technologies and new service principles and definition, which is very important in order to innovate all the time. A vendors partnership and alignment with latest open standards. It's actually extremely key. Without this level of partnership with vendors, this will be extremely complicated for any telcos to achieve any massive change and any sense of innovation in the future, and greatly facilitate expansion with hyperscaler partners. Hyperscaler are essentially based on cloud native principles and tools. So this is why adopting the same kind of tools and principle are extremely important. So why disaggregation in cloud native is a necessity then for MNOs and CSPs? Simply because one, well, you could say that in the past, the network functions operated by telco were made on tools and processes made to accommodate innovation and legacy services. But going forward, we can see naturally that for example, today cloud native orchestration is extremely important, and it means that the telco end-to-end management and orchestration will no longer take responsibility of that, will overlook the assemble, but will delegate these responsibility to lower layer capable tools. And we can see already that disruptive vendors align themselves towards more cloud native capabilities and open standard. Three is going forward, we can imagine that both CNF and VNF will converge towards cloud native operational tools. They will leave the telco kind of space to embrace all the same operational tools, and all vendors going forward will embrace cloud native principles. And going forward, we can see that X and Fs. So the dependency on hardware will still remain for some specific functions. Nonetheless, they will be based on the same orchestration methodology and operational tools. And also the dependence and reliance on telco management and orchestration tools will disappear over time. So this is why I wanted to present to you today. I hope you enjoyed the session and enjoy the transformation journey. Thank you. For any questions, please don't hesitate to ask any questions. I'm also available during that session. Thank you.